All right. Welcome, everyone, to an awesome Let's Talk Manufacturing live event. So excited everyone's here today watching on LinkedIn Live, on Facebook Live, on YouTube. Exciting for everyone to be here today. Today, we're going to be really talking about how programming and robotics is continuing to change in the industry. So much fun conversations that are happening between podcasts, live events, and blogs. But I personally love it when the chat is here as well, interacting to make it more feel like we're back to those real life events. And I don't know about you guys, but I literally have a calendar list of all the events I plan on checking out this year, just so I'm like, okay, I'm gonna get my hotel booked here, my flight here. I am finally getting out of my house, getting out of the office, and going to a live trade show again. And I don't know, I mean, for Aaron, you've been to more trade shows than probably all of us have combined. You know, at the end of a trade show, you're like, I am never going to a trade show ever again. And I think I say that every time I'm done with like a 4-week trade show, I'm never doing one again. This is ridiculous. I don't want to do it. And then here I am saying, I can't wait to the next trade show. So thanks everyone for joining us. Allan, Aaron, Ben, so glad you guys are on another Let's Talk Manufacturing live event. So let's go ahead and let's go around the table. And let's go ahead and just do some introductions. I'm going to start with Allan, and then Aaron, and then Ben will move to you. So let's start with this. Introduction, who you are, a little bit about yourself, and we're going to Memorial Day weekend. Hopefully all of us have Monday off, or hopefully take some time off. Ben, I know you work 24/7, so take some time off Monday. But, into yourself, and then what is something you're doing over Memorial Day weekend? Allan, we'll start with you.
Yeah, so Allan Gibson, Director of Advanced Robotics and Automation from Estee Lauder. In the past, very similar role at Stanley, which is where I first met Ben. And so I bet we're now, 4 or 5 years into this, Ben.
Yeah.
So certainly a long duration there of a friendship and a business partnership as well. History speaking, right, industrial engineering degree, really have been interested in robotics since a very young age. I think I won my first robotics competition at the age of 7, right, when Lego Mindstorms were a massive thing, right? So
nice.
It's been something that's been part of me for a very long time. So certainly a lot of interesting, developments in my career. It's evolved rather quickly, I think, in a lot of ways through mentorship and through collaborative sort of partnership across the board, right? Nothing else, really, too universal with me. The piece about this weekend, going to visit family for we'll say the second time, my wife's side of the family since COVID. So about a year or so now that, we've been apart. So it'd be nice to get back and see everybody again.
Great. Awesome. Thanks. Aaron, over to you. Who are you? I think, who, besides who doesn't already know you, give us, what you are, what you do, and what you're doing.
Okay. Aaron Prather. I'm the Senior Advisor for the Technology Research and Planning team here at FedEx. My team takes care of the cutting edge stuff, and we're always looking for new products, new technology, new robotics, new automation, you name it. And seeing is it ready to enter the FedEx ecosystem. My team will run the proof of concept, whatever you want to call it, see if it's ready to go, and if it is, we'll hand it off to the team. They'll own it the rest of its life, and then we move on to the next thing. So yeah, we get to play with all the nice shiny toys.
Brand new, no one else gets to see. You guys see it first.
We get to see it first. So it's a great place to be. It's sometimes a little nerve-wracking because we are trying out new things. But it's something that I wouldn't trade for the world, and neither would any of my team members. My team is always looking for all these new things, and we love what we're doing here. Memorial Day weekend, I'm actually going to get on a train and go down to New Orleans and see my parents. Now that we're all vaccinated, and enjoy some time down there. Probably will do some reading and writing on the train trip down, and then busy week next week. Literally come back Tuesday for another one of these shows with another organization. So staying busy.
It's gonna be fun. And then Ben, let's move over to you real quick.
I'm a little jealous you're heading down to New Orleans. I love that city. It is a great place to spend a weekend or a week. Ben Gibbs, the CEO, co-founder of READY Robotics. Been running the company now for about 5 years, ever since we obviously started. From a weekend plan standpoint, not doing anything nearly as fun as it sounds like the other two guys are. I'm they're really looking forward to it. Nice chance to hang out with my wife and our 21-month-old daughter just for a few days, which for those of you that have kids know that when you're hanging out with a kid that young, you don't really have any time off, but
exactly.
It's still a good time.
Absolutely. So thanks everyone for joining us here today in chat. I see a couple people. Chris, welcome. Glad you're here as well. We see Chris Mao in chat. If you guys are here on LinkedIn, YouTube, Facebook, let us know. We see your comments, and we're glad you're joining us. So we're going to kick off the conversation around READY Robotics. I don't want to get into the details necessarily on the product right away, but Ben, you're a millennial like myself. I mean, it's pretty cool with the fact that we both have matching Star Wars sets in the background. Aaron, we know you're going to get one eventually. We'll keep harassing you until we see a Lego set in the background. But you're a millennial. You have the same idea of passion for creating innovation, seeing something in the industry and saying, I want change. I see a need for it. I want to push something out there. You went to Johns Hopkins, and right out of Johns Hopkins, you kind of started this idea for READY Robotics and went right into getting some venture capital. So run us through your story and why READY? Why READY Robotics? How did this come about? Because it's evolved over the years from where you guys are now. How did that start?
Yeah, so I actually spent several years after I graduated working at Johns Hopkins. I worked in the Johns Hopkins Technology Ventures office, where I started off as an analyst there. And by the time I left, I was actually overseeing a couple of their translational investment funds and their engineering portfolio, which ran the gamut from microfluidic systems and organic electronics and all sorts of other really interesting cutting edge stuff. And of course, robotics. They actually had a NSF-funded engineering research center there focused on robotics. It's considered one of the top 10 institutions for that. And as my job there evolved, part of what I did was help researchers push their inventions and discoveries out into industry. So corporate partnerships and licensing, but more often than not, startup companies. So I would help 3 to 5 companies a year spin out into the world, get some of that early stage money. And that's actually how I met my co-founder, Kel, who's doing a PhD in robotics there, focused on the idea of making it easier to interact with robots. He had done it previously with space robots and mining robots at Carnegie Mellon, and then come to Hopkins to do it again with surgical robots. And one day we got, Johns Hopkins literally got a call. The front desk got a call from the owner of a local steel plant who said he had just purchased some robots at a fire sale and didn't actually know how to set them up and use them. And could we send someone out because Johns Hopkins knew about robots and he needed some help with robots. And so Kel went out there and saw it and came and talked to me about this idea of making it easier to set up and deploy a robot system in these high mix environments with like a mobile cart station. We had a UR robot on it. It seemed like a pretty intriguing idea, and we went out and started to raise some venture capital for that. I found this photo of you. Picture.
So I found this photo of you, Ben. So this is a fantastic photo. So this is kind of what you're talking about here, right? The old workbench. Just the cool stare from you, Ben. Back before you got the blue glasses that said, we're making automation badass. That's what this was about, right?
That's what that look was totally going for. Totally not a deer in the headlights look. I like the way you describe it better.
Watch out, pro sports. Automation is the future.
That's right. So, we went out there and we started deploying this, right? Because, one of the things VCs always encourage you to do is get out there and get customer feedback as fast as possible so that you can evolve the product and figure out how to actually get what they call product market fit. And so we built that. It was called the TaskMate at the time. That evolved into what we later called the Forge Station, which had a little bit more of an updated look, was IP54 rated, still used a UR cobot. The more we went to market with that, the more we heard from people that, hey, we love this programming interface, but we would really love to use it on our FANUC robots or our ABB robots or our 𝐅𝐨𝐫𝐞 robots. And as we dug into that more and more, and we found this just massive fragmentation problem there where every robot arm OEM has their own programming language and interface, we said, this is what we should be solving for. Not just making it easier to deploy a mobile system in a high mix environment, but making it easier for everyone to use whatever robot they want, right? And that's part of our whole philosophy is you pick the right robot for the job. Don't have to worry about these different programming interfaces. And that was the evolution of READY Robotics. And I've been very fortunate to work with some really amazing people over the years and find some really fantastic investors as well. And as you all know, we just launched Forge OS 5 a couple weeks ago, and we're just tremendously excited about where that's going to take us and hopefully the industry as well.
So we talk about, you mentioned at the end of it, Ben, where all different types of robots. When we think of all different types of robots, Allan, I want to jump this over to you because you're currently the director of advanced robotics for Estée Lauder. And, going in your background, you went to Texas Tech, you got an industrial engineering degree, but you spent a lot of your earlier career at Stanley Black & Decker looking at their global automation. You were the global automation and robotics manager for Stanley Black & Decker. So, how many different manufacturing facilities were there? And, talk to us about your role a little bit. And when you look at such a large manufacturer, with you specifically focused on automation and robotics, tell us what that was about.
Yeah, so I was part of a new group there. It was an Industry 4.0 group run by Sudhi Bangalore, and there's a lot of engagements that Sudhi does as well. So if you're interested in hearing more about his philosophies, they're certainly out there. And really what I was doing there was I was in charge of working to develop a strategy to deploy automation at scale, right? Up to that point in the business, each plant had operated independently, even though they made very similar products, were even part of the same business units. And it was the opportunity for the business to look at it more at a corporate level and deploy at scale. So, those key focus pieces around time to value, right, and the time to deployment, which are historical problems within automation when you're custom building everything, were some big focus areas, right? So I focused a lot of my efforts on platform development and flexible automation that was able to be deployed into similar applications with little to no engineering other than end-of-arm tooling, right? Application-specific sort of engineering. But we treated the 80-20 rule, right? 80% of the equipment didn't change and 20% did. And, during my time there, right, so Stanley's a very diverse company, right? They go from making sliding doors when you walk into the Home Depot and Lowe's of the world, right? So those electronic doors, they make small screws that hold iPhones, iPads together. They make RFID tags and, medical devices to track babies in hospitals, right? To make sure that they're not leaving without the hospital's knowledge. And then, of course, power tools and hand tools, right? So that's a very diverse sort of business. And we were responsible with making sure that we could tackle as large of a group of types of projects with those platforms. So over the time there, I visited 55 of what was at that point around 110 manufacturing sites globally to really understand the problems and the similarities between those different business units as well as the different companies, within those. So, tremendous amount of effort was put into flexible automation there.
Yeah.
And very similar now to my time at Estée, right? So the role at Estée is an expansion of essentially what I did at Stanley, but it also has some responsibility in the warehousing and distribution space. And now it's also of sort of all capital equipment. So even equipment that isn't the cutting edge, right? It's also the capital management of making sure that the equipment that we're landing, we're phasing out equipment, we're phasing in new equipment, and that whole strategy piece on all of the capital equipment that's going into the organization. So it's been fun. It's certainly been an expansion and a challenge. But at the core of everything that I do is robotics, right? I'm a firm believer in, although we may not need the flexibility of a 6-axis versus a 4-axis today, it's only a very small change that someone in brand marketing makes that makes a $10,000 difference in robot, essentially a line that's not running. So I've always been on the side of adding a little bit more flexibility into that design, and then through software and software iterations, right? So almost how you interact with a PC, where the USB port is a USB port, and if a new piece comes out, a new corded mouse, we'll go back to that part, right? It doesn't matter, right? You have the drivers that are developed, and that new mouse works, right? Yeah. So I've tried to take the sort of PC-based approach to automation by designing that standard framework and then iterating on the software.
So, Aaron, let's jump over to you real quick. So, I want you to get some thoughts on this. You're an industry expert in a lot of fields. You've been at FedEx for 26 years now. We were joking about before this. 26 years ago, and not to age you, Aaron, but I'm going to pick on you, right? Because the millennials outnumber the older generation, at least in this conversation for once. Mm-hmm. I hope in more manufacturing as a whole, we'll get there. But 26 years, I would have been entering kindergarten. Allan was not even in school yet. So you've seen a lot of the stuff in the industry. And you see a lot of robotics. You're, like you mentioned, you're the first touch when it comes to new technologies, new automation. And I'm going to jump a little bit later in the conversation when it comes to your passion for robotics and skill gap. But Allan mentioned something really important earlier, and I want to go back to that. And that's the idea of time to deploy and time to value. When you're looking at new robots, new technologies, there could be awesome technology out there, but if it's going to take you 18 months to deploy, FedEx doesn't work that way. You guys are a speed company. I literally ordered a package yesterday and Phoenix, and it's getting 1 day shipping, and it will be here tonight, 1 day later. It's about speed. Mm-hmm. When and manufacturing and the deployment of manufacturing equipment is no different. So what does time to deploy mean for you in your position, but also when new technologies are being looked at for FedEx, for example?
Yeah, I mean, the biggest thing that we face is, as you said, we really can't take our operations down of like, okay, we're going to install some robots, we're going to shut the facility down for a while, and we'll be back with you in 6 months. Customers aren't going to are not going to take that delay. So when we look at these new technologies, we're looking at it from 2 points of view. Of if I have a greenfield site that I am building from scratch, that I am adding to the network, that is one place I can definitely put some of this cutting technology right in, right away. Easy. I mean, I can hit those deployment schedules because it's just tied now to the greenfield site coming up and being operational. Mm-hmm. So we're very much looking at those. We have numerous facilities coming up online over, we're looking 3, 4, 5 years out of like, these are how these facilities will roll out. The flip side of that is we also have billions of dollars in brownfield sites across the globe. Mm-hmm. And it's how do we introduce these technologies to those facilities without interrupting the flow of those. Mm-hmm. And one of the things my team is tasked with is actually we have a huge facility here in Memphis, 110,000 square foot facility where we can actually mock up some of these operations and figure out how we're going to interject the technology into those spaces ahead of time so we can do those quicker deployments even into those brownfield sites. They're slower to go, but it is possible. And so the biggest thing I always stress to folks that are new to this, because they'll have some of these same thought patterns of, I can't take a line down. It's like, well, how have you broken down the process where you can introduce robotics into some of your brownfield sites quickly and get that return quickly? And I think one of the things that's great about the Forge platform is you can do that, those kind of things. You can actually get a lot of these robots running quicker using a program like Forge OS, because you're shrinking a lot of the stuff that holds you back, like being able to have personnel that knows FANUC versus Yaskawa versus UR versus all that. You can still come up with a quick use case solution using Forge OS and get that stuff out there as quickly as possible and close that deployment
Absolutely.
runs.
So one thing I think of, and adding off of that, Aaron, when you think of time to deploy, time to value, I think a lot of times when we look at, hey, can we automate this process? When you're a small to medium sized manufacturer, a lot of times you're not running 20 million parts a year. You're running a batch of 500, a batch of 5,000, a batch of 40. And a lot of times the justification is, do I do this process manually versus do I automate this process? Is how quickly is my changeover time?
Mm-hmm.
How quickly can I do machine tending? And if I'm running 40 parts, but it's going to take me 4.5 to 8 hours to set up time, that's not worth it. I could just have an operator stand there and do it during that time, and the investment's there. So I think time to value is another conversation. And Al, actually, I want to jump back to you, Alan, on this. Is when you're out there and you're looking at robotics and you were saying, okay, these are all the different processes that we're automating. That's a big thing to say, hey, we can automate this process, but if it's going to take 6 months to do it, it's just simply not worth it.
Yeah, and in a lot of industries, especially cosmetics, right? The packaging and the business evolves so quickly that if we were to land a project that took 18 months to land, there's a high likelihood that half of the products that we initially conceived to run on that line are not going to run on it. So even in a regular project, right, we have to design flexibility just purely because things change so quickly. And when you talk about time to value and in this ease of programming, I think that it's not just the piece around being able to deploy quickly. It's also the ability to make slight modifications as things evolve to get a longer utilization out of your asset by people that you have internally. It's very rare that corporations even have a staff of people that
Absolutely.
have robotic programming expertise, right? So
Absolutely.
we do have to take it down a level to where we can do that sort of reteaching efforts by the staff that the businesses have, right? To some degree, right? So there's definitely a lot of value there. And I think that there's sometimes misconceptions about why collaboratives took off, right? I think that collaboratives are sold to the market in a way about them being, you can work around them, you don't have to guard them. But my feelings about why UR specifically took off was because of the interface and the ease of programming. And when that becomes adopted into the industrial manufacturers, we're going to see a lower consumption or a slowing down of the growth of collaboratives, and then the continued pickup on the industrial side of things. Because I think at the end of the day, manufacturers want the most production possible, but they need to be able to maintain and run that equipment, right? And that's a bit of a divide that READY is filling, and that's really what originally brought me to READY and Ben and Kel very early on, was needing that ability, but not wanting to be exclusively tied to a single manufacturer that in a lot of cases didn't have the specific arm that we needed when we were in a niche application or something like that.
I think you look at it, it's a couple things, right? When you look at the medium age for manufacturing right now. You have a lot of people who've been around the industry for a long time who are saying, no, this is the process and this is how we're handling it. And there's a certain intimidation factor for a small to medium sized manufacturer, which is over 90% of manufacturers are like under 50 employees. That's just the skill of it. And a lot of companies saying, well, a robot's a risk, because what happens if that one person who we get it leaves and doesn't know how to program the robot anymore, or this person who hasn't, gone to a lot of robot programming or is a controls engineer, and they don't have with the current demand for a controls engineer being 6 figures, we don't have the resource capital to have a guy on site to have a robot, but we can't pay him for him all the time because it's just one of those things where there's no cost justification to have that skilled of a guy around all the time. So
right.
It's also a struggle for some of the larger guys though too. Like that was one of the things that surprised me, is I had a conversation with a tier 1 auto manufacturer, and they pulling in some of our systems, and I asked them why, because you guys have all the robotics expertise in the world. And he said recruiting was becoming increasingly difficult for them because they would go and talk to recruits from, Stanford and MIT and sell them on this, like, hey, you're going to work at this really dynamic, awesome company and you're going to get to use robots. And then here's the OEM teach pendant that you're going to program on that looks like this like graphic calculator from the 1980s. And they're like, oh, I'm out. I'm going to go work for Google or Apple or people that actually have a modern tech stack. And those companies make amazing arms. They're really, really good, but the programming interfaces haven't evolved for a long time. And Alan's right. I mean, I think that's something that you are demonstrating quite aptly to the market, was that ease of use is very important, and there's a tremendous hunger out there for that.
Yeah, and you look at what the new, and I think this really evolves into the new generation, because manufacturing is just changing at this unbelievable pace. I mean, you look at the robotics industry as a whole, and you look at the giant, which is overseas now, where by next year or 2025, China will be integrating more robots on an annual basis than the rest of the world combined. So that just puts it in perspective real quick when we think about, robots is, a very automation, not a third world country thing, but a leading edge Western country. That's not the case anymore. Automation robotics is a global scale that's happening. So when we look at how manufacturers are adapting to it, they're going to have to leverage future generations. And I think the main reason for that is because us millennials, us Gen Zs, we grew up with technology. We grew up, and I literally have 2 phones in front of me, with touchpads, with this idea of a touch-based interface to program, to interact, to move things around, to slide things around. That's just how we're growing up now, as an idea where before, when programming and things first came out, back with, Aaron back in the 1930s and 40s, I'm sorry.
Just remember, Aaron, revenge is a dish best served cold.
Oh.
I owe him a couple beers anyway, so I'm gonna add that. But back in the day when programming was first out, it was that line-based code of how you set stuff up and how you program, and it was great because that's what the technology was at the time. That's how you wrote things. That's how you program things. But why is robots and automation not adapting to how we're interacting with things now? If we can slide things around on our phone to play a game or move things, why can't we do that same operation? I think that's what we're looking at as well. But that's making robotics and automation more attractive to the next generation. I think even, in fact, when we look at the first quarter of this year, Jeff Bernstein, who we all know at A3, he mentioned that, hey, Q1 of this year, the U.S. bought right around between 9,000 to 10,000 robots this year in Q1, which is great, up 20% from last year. But I'm talking about this fact specifically, and Ben, I'm going to bounce this one back to you, right? Robotics for the longest time has always been this idea where it's automotive, high rate of product that we're out there. But Alan, you'll be glad to hear 72% of the increase for robots this year is in life sciences, pharmaceutical, and then cosmetics. 72% increase compared to last year when it comes to robotics and automation. So, Ben, why is that? Why is more, and what are you seeing when you're working with different end users on this technology? Why are you seeing more companies turning to this as a solution? And then, Allan, add on to that with your experience at Estée Lauder.
Given the speed I've seen Allan work, probably 50% of those robots are his own personal responsibility. He's probably just been rolling them out nonstop. But I mean, I think overall, we're seeing these type of increases because we need it, right? I mean, there's this manufacturing skills gap where we just have a number of unfilled jobs here in the U.S., but there are other countries that suffer with labor shortages as well, and it's a global problem. One of the things that surprised me when I visited China a few years ago was they were complaining about labor issues as well. It was a reverse demographic issue, though, where people would come in, they'd start work at 20, and then after a decade or so of working in that industry, they'd saved up enough money that they moved on to something else. You lost all of that expertise, all of that knowledge, and there was just this nonstop churn. And bringing in new people is hard because you have to then go through that whole process of upskilling them, especially with the current complexity of the technology. And I'm obviously a firm believer that you can make this stuff a lot easier. And there are people that can pick it up then once it looks like it's no longer this intimidating thing. Like, we work very closely with an organization called ecammie. Aaron does as well, right? It's reskilling former coal miners in Eastern Kentucky to go into manufacturing. And one of the things we do is teach them how to use robots. And because we gave them such an easy interface, they can pick it up quite quickly. And then they spend more time thinking about how they make these tools productive in a manufacturing setting rather than struggling with that programming interface. And these are really clever guys. Like, they are very good with the mechanical side of things. And we give them this easy interface, and something that previously they thought was impossible now seems achievable to them. And I understand that quite well. The first time I saw a FANUC teach pendant, I was like, are you kidding me? I'm supposed to program with this thing? I had no idea what to do with it. Like, I couldn't program a robot with a FANUC or a Yaskawa teach pendant or any of those traditional pendants because there's so much complexity there.
Yeah.
And making this stuff easier is how we can make it much more widespread.
Yeah, and I think
I'm
that
a firm believer we're on the cusp of an explosion there.
Yeah, absolutely. And Ben, you're hitting on a really important piece, right? That I think that most people view the advantage of the allure of robotics and think to themselves, wow, that's very complicated. But the difficulty there, right, is that the challenging part is understanding the process, right? Now the challenging part is also programming the robots, but it doesn't need to be. That process, though, and the knowledge that most people have that work in a manufacturing facility is really the real challenge that will remain, right? And so simplifying the things around that to enable the person in the facility that intimately knows the process and knows when I do XYZ, I get a better result on that product and that part is the really important piece that we can't lose, right? So, I mean, the skill of doing the actual programming is evolving, right? With new things like what you're offering, but also on the automation side in general, right? You've seen a lot of trends towards more, I would say, scripting-based programming languages opposed to ladder logic, right? Because although ladder logic's easier to read, right, from an electrical technician or something like that, in most cases, right, companies aren't going to that level of depth of troubleshooting in facilities anyway, right? So you've got ladder logic, so it's easier for a technician, but the technician never reads it. And essentially a lot of the cases you're falling behind because a lot of the innovation and the new talent from a software engineering perspective is learning structured text languages, right? You're not learning ladder, right? Ladder isn't taught it's taught in technical schools, right? But it's not taught in universities. Aren't software engineers coming out of university that know ladder. So it's a big divide, and we're already seeing a shift, right, where you have to move to that PC base. So one, you can attract new people, like what Ben described earlier, right, where the Stanford and MIT engineers, that come out don't want to use the teach pendant and don't want to learn ladder because it's not a multi-industry sort of thing, right? It would pigeonhole them into a certain place, where a broader set of software engineering background can be applied to automation. And when you partner that person with someone who has some intimate knowledge in the manufacturing process itself, it's a beautiful relationship. You know, and that's a big shift that's happening overall.
Aaron, let's shift you real quick. We brought up ecammie, so I have to put the plug in anyway. And you know, there's a fun event from ecammie coming up. So you know, tell us more about. And I think this audience would be great to hear about this. Just from, it's a great story to tell on how the industry is changing. What is ecammie? What's happening? And then of course, you know, what's happening next week. You know, READY Robotics is going to have some stuff there. I'm actually going to be there virtually, driving around on a robot. So I have a robot going down there that's going to have my screen on it. I'm going to be zooming in and driving around. You know, what's ecammie? What's happening? Why is that important to the industry?
Okay, I mean, yeah, I mean, ecammie is a great story, and it just shows you what can happen when you embrace technology. Ecammie is in Paintsville, Kentucky. It is in Eastern Kentucky. It is just a stone's throw away from West Virginia, Tennessee, Virginia border. It is the heart of coal country. And we all know what has happened to the coal industry over the past couple of years. And mines up there have been closing left and right. And ecammie started as a retraining vehicle to retrain those former coal miners, starting out on advanced manufacturing. So Gene Haas did a great thing, and he donated dozens of CNC machines to the facility, and that got the first couple classes going. And what was interesting was that some of the early graduates actually got hired by the growing robotics industry there outside of Lexington, Kentucky, that supports the Toyota manufacturing sites. Yep. So automatically, we're starting to see that these guys with no training in robotics actually made really good robotic techs, because what they were learning on the CNC machines actually sort of already started translating into robotics when it comes like to XYZ coordinates and how all that works. It's always funny is there's this 10-page article that was written by MIT a couple years ago arguing, is CNC machines robots or not? And for 10 pages, you see them going back and forth trying to figure it out. And of course, at the end, they conclude that they're not robots, but they give a great baseline. And I think Ben's team, when they went to ecammie to introduce them to the Forge OS, I think even Ben's team was blown away how quickly these guys picked up on how to program robots based off of what they had already learned. But the whole thing is they still, these guys in the video you just showed, Jake, those guys had never seen a robotic arm in their life. No one in that class had ever seen a robotic arm, had never programmed it. And in 10 days, they went to lights out production. How amazing is that? We took folks with zero experience in robotics, taught them using the Forge OS platform, and they were doing lights out production. So what's happening next week is Ben and I are returning to ecammie, and we're going to do a grand opening of their new robotics lab where they have mobile robots roaming around. Jake's mobile robot is there and is already roaming around. I think he's actually wearing an ecammie smock with everybody else.
Oh,
I think on my way,
I haven't seen that one yet.
Yeah, well, the whole thing is now I think I'm going to stop and get a Cincinnati Reds baseball.
No. Don't
Here comes that revenge part.
So, or would you prefer a St. Louis Cardinals?
Oh God.
So we'll pick our poison here soon. But
hey, Chicago Cubs are leading the NL Central. They won today. They are in first place in the NL Central.
Yeah, but I think they're tied with the Cardinals if I look closely at those.
Yeah, Cardinals are just the first loser.
So, but what's going to be great is we're going to show the guys have a Yaskawa arm, they have UR arms, and they're going to be able to show off those robots using Forge OS, working on various CNC machines around the facility. So it's a great story of like, So when we talk to small and medium manufacturers of, oh, I don't know if I can do this, and like, if you, as Allan said, if you can break down your process and find that use case that makes the perfect sense, you can introduce robotics to your facility. It is that first step though. You got to find the use case that makes the best sense for you.
Yep.
And then getting into the programming and all that, yeah, that's a whole other story. But the whole thing is with tools like Forge OS, there's a way to do that now. But absolutely, is what Allan said. You have to find that first use case.
And the one thing is I want to bring up is it's addressing employee retention. You can take here's the best part about it. You can take people who already understand your processes, already understand how your system works, what is a good part, what is a bad part, and you can leverage their expertise of already understanding it and then teach them the programming. Rather than having a person coming in and programming it and setting up the system, you can leverage someone within the company already who understands it all and then teach them a simple interface. So let's jump into that and everyone here, and real quick, Chris, go Tigers. I'm no longer buying you lunch next week. So I just wanted to put that out there. But Chris, let's talk about that real quick. Forge 5, you guys just did a nice release a couple weeks ago. Still, once again, awesome music, by the way, with that whole entire thing. I love the music. And I want to encourage
you guys have. That's Kirk on our marketing team. He always manages to find just the sickest tracks for that stuff.
If you guys have questions, please, we're all watching the chat. We all see the chat on YouTube, on Facebook, on LinkedIn. If you guys have questions, let us know and we'll be glad to answer. But Ben, let's talk about Forge OS 5 and let's talk about this idea of like no code programming. Walk us through the interface and why this Forge OS 5 really came about.
Yeah, so we have both no-code programming, and we also have more traditional programming available. And when I say traditional, I mean C++, actual computer programmer programming. The no-code side of it are apps that we've developed ourselves. So Forge OS 5 at its core is a hardware abstraction layer, right? So we take not only these different interfaces from robot arms, but also for all of your other peripherals, things like that, all the hardware that you need to control a robot cell. And those interfaces get abstracted away through our software. And then everything is now available through a common set of APIs. So you can send a single API command that, depending on what robot you have hooked up, would move a FANUC robot or an ABB robot or a Yaskawa robot, right? And that's part of the true power of what we've built there. And then using those own APIs, we've created these no-code apps on top of that. The flagship one is the one we call Task Canvas that you saw in some of the ecammie video there, one of the earlier versions. That putting together building blocks into flowcharts. And you can build out very complicated and sophisticated programs if you want, but you can also build out very simple ones quickly as well. And that type of no-code approach is similar to what we've seen historically in the PC industry. The killer app for PCs way back in the day was spreadsheet software. And spreadsheet software allowed you, without programming, to be able to compute sums and do other types of accounting operations without being a programmer.
Yep.
And that's what Task Canvas does in the robotic space. It allows you to use robots without having a PhD in robotics. And that means you can take former coal miners or lathe operators or idiot economists like me and turn them into effective robot programmers and users. Much in the same way all of our computer technology, right? Like Windows, Excel, all the email programs we use, we don't have to have a PhD in computer science to actually use these things anymore. And thank God, because if we had to write 50 or 100 lines of code just to send a simple email, who would ever use email?
Yeah.
Instead, you click a couple of buttons.
And
it's that no-code mentality that I think is going to really help spread this far and wide. And because we have this abstraction layer, you can now focus on the value-added aspects of whatever it is you're doing. If you're an end-user programmer, it's setting up your tasks. If you are a developer who wants to create your own robot, solutions and automation solutions, you don't have to worry about the lower-level integration stuff anymore, right? And you can focus on the part that you're actually creating value with, not recreating the wheel over and over again to get the FANUC to talk to your key ends camera the way you want it to, or things of that nature. And that, I think, is also going to be transformative because it's going to allow these smaller teams of developers to create things in the robotic space and have these massive outsized impacts, much in the same way we've seen with smartphones and with PCs historically.
Yeah. So a couple questions. Here's one for you quickly, Ben. Do you know if the Omron TM collaborative robot can be programmed with READY?
The answer to that is not yet. We actually own a couple of the Omron TM cobots, and they are on our roadmap to integrate with. I can't promise you that it'll necessarily be this year, but it's certainly on the roadmap to get done in the foreseeable future.
So stay tuned.
Indeed.
And that's the one thing I want to talk about. As you guys are developing, there's also an SDK.
Yes.
Out there. So that's the other thing as well. When you go through your website, you have this idea where you have the solutions on the software, but you also have this SDK where people can take and add on to your platform to continue to grow the ecosystem. Let's talk about the ecosystem for a second. When you guys announced there's all these different robot brands that are out there that you guys are a part of, but for me, I think the part that I found most impressive was the integration of like the 200 other manufacturing companies that are not robots. And I think, Aaron, you like this when you look at technologies and you're integrating, it's robots, and Allan, with you at Industry 4.0, robots are a part of the solution. They are not the solution. So when we look at how we can do this, going back to the idea of time to deploy, if you want to add a conveyor, you want to add a camera, you want to add a ATI end of arm tool changer, that's where the value of time to deploy happens within, Allan, when you guys are doing switching over, or Aaron, when you want to integrate or automate something, someone who is that, go ahead and add on to that. Let's talk about how it's not just the robot, it's all the value behind it makes it simpler. Anyone want to add on to that?
Yeah, I mean, in the way that I look at it, the robot is a tool, right? But there is so much. If you just did the robot, it would be a very small part of the overall software that's needed in order to build any equipment. Mm-hmm. So it's a very flashy key piece of it. But just having a robot actually would be completely useless, right?
Yep.
Because you wouldn't have a gripper, you wouldn't have any, there would be no, sensors to tell the robot when to begin its work and end its work and things like that. So it's a pretty key piece of it, right? And it's enabled a lot of really cool things to be done. But without those periphery sort of devices, it's, non-existent essentially.
Yeah, absolutely.
And I would just add on to that. The whole thing is I mean, when we're talking, like when we're teaching like the students at ecammie on like robot safety, we give them the alphabet soup of all the ISO, RIA regs, everything that's out there. And as Allan said, the robot's just one part of that. It's actually your whole application. And so when we talk to the students and we teach them about doing their risk assessment, it's like, yeah, I don't care that you got a UR collaborative robot. The application is what's going to drive your risk assessment. So the whole thing is this whole concept of a collaborative robot that's safe out of the box is always a myth. And I know that Jeff at A3 is always fighting against that, of like, just because you bought a collaborative robot doesn't mean you can get out of doing a risk assessment. It's your complete package.
Yep.
So yes, the whole thing is it's all that integration of adding the end effector and extra sensors and conveyor belts, and how's all that going to play, and how easy can you switch those things out as your things change. That's a big thing I know for a lot of these manufacturers is they do those small batches. They're now going to switch.
Yeah.
And giving them tools that allow them to switch quickly is how they're going to adopt this technology much faster.
And I think that's the one thing as well when we look at is the selection of the process, going back to Allan, what you said, between choosing a collaborative robot or choosing a industrial robot, that's one of the great debates. And I see one, I just saw a post yesterday even talking about it, where, people are like, oh, I hate this idea of the collaborative robot, because anything you could do, you could put it in a fence and you can make it more efficient. And then you have the other side where it's saying, hey, collaborative robots offers more than just the collaboration space. It's offering the ease of use in the programming. So you kind of have these two going back and forth with each other, but the end goal is, how can you take processes that are not automated right now and automate them? And I think that's where the discussion needs to be happening more, rather around the great debate of, what's better. It's how easy is it to use and how easy is it to implement. Scott Litterman, he's the CEO of Mission Design. He made this post. Easy to use software is a key part of allowing the entire team to spend more time at making the system and the process more repeatable and robust. Right? Time is limited. Easy to use software is a tool for providing usable, reliable, and maintainable systems. Right? And everyone has time. And if everyone can contribute to a solution, it's a lot more valuable than just a single individual. So we're getting close to wrapping up on time. If there's more questions or stuff that want to be asked, go ahead and ask them. We're watching the chat. But, we're going to go ahead and wrap up some stuff. Allan, anything else you wanted to add in terms of just what you're seeing in the industry? Not necessarily around just the ready and settle, but anything else you want to add that I think people could take away from this conversation?
Yeah, you touched a little bit on the growth outside automotive, right? And I think that's largely been driven by, one, the use of the ease of use piece, but I think it's also in a lot driven by the flexibility and the agility that robots can now deliver. And that hasn't been something, although they could sort of historically always do that, right? Just from a pure mechanical perspective, it was always that periphery and the way that they were designed that created those traditional dilemmas. Now, really, the advancements in vision are what's enabling them to branch out of automotive and do a lot more in the, I would say, assembly space, where vision in a lot of ways is how you get your agility. So, if I look at sort of existing equipment, from 5-10 years ago in every company and plant I've ever visited, right, there's very little camera-based vision, that's used. And what you've seen today is companies are now relying a lot more on software, which is great to see. But the piece behind that is really, a lot of it's driven by vision and the advancements in vision technology to do a lot of those things through software adaptations, opposed to sort of fixed tooling or change parts and things like that. So there's still this, concern over that, because I think when vision first came out, there was a lot of inefficiencies or loss in production because they weren't as robust as they are today. But vision has really come a long way. And that is what, at least in most of the cases that where I deploy equipment into, that is really one of the big enabling factors that allows us to move with speed and not worry so much about the change over time taking 4 hours and things like that, right? Because we could do much more through software.
Yeah. Aaron, you could probably speak on vision and robotics and how your world is changing within the use of vision. And we're just talking just vision anymore. We're talking AI vision. We're talking how deep learning and artificial intelligence within, product selection and identification is changing. So, add on to what Allan said, or all of you kind of do your wrap up as well, Aaron.
No, I mean, Allan hit it on the head. I think where the biggest breakthroughs, and especially this is what has opened up robotics into the logistics space, is vision and AI. It's one thing to have a robot in a factory that's picking and placing the same part over and over and over again. Yes, I mean, that's some easy programming. And yes, there is no real such thing as easy programming, but that's why manufacturing had always had a huge leap. In logistics, we are dealing with so much diversity when it comes to product mix of what we're having to deal with coming down our line every day. That's where the breakthrough happened. And when that vision and that AI started having those breakthroughs, it opened up a whole new world to robotics, because now the whole logistics space opened up. And that's why we can have our pick and place robots now in our facilities, picking and placing packages, that are different from one thing to another. It's interesting is I'll watch some of our robots and they're picking up an envelope, then they're picking up a black bag, then they're picking up a box, then they're picking up this pink glittery looking thing that I don't even know what it is, but that's what the customer shipped it in.
Yep.
So it's just this ever-changing thing. And not to go ahead and plug something else, but A3 is having its Vision Week in 2 weeks. I am on the panel that is kicking that off with Eric Neves and from Plus One, and Cognex will be joining us on that. And so that's and it's free, guys. So go to automate.org to sign up for that if you want to really get it to listen to some of the folks in the vision space.
Yep.
And where all that's going. So, but Alan's absolutely correct. Vision and AI is where the next cutting thing is.
It's that idea of you're no longer doing one part a million times. You're doing a million different parts one time. And that's how things are really changing. So, Ben, let's go ahead and any final thoughts. If any other questions kind of wrap up, we'll jump on those. But any other final thoughts that, Ben, you wanted to add?
Yeah, I mean, I think Eric at Plus One has really demonstrated the value of that type of fusion of vision with robotics, and he and the team should be commended for that. They do some pretty great work at that company. And I would say that just to wrap up, one of the things that Aaron constantly is highlighting and touching upon with all of his LinkedIn posts is this revolution that's happening right under our noses in robotics outside of the traditional spaces of automotive and electronics. And I don't just mean other manufacturing verticals. I mean things like restaurants and car washing and food prep and farming, that I think we're right at the cusp of this explosion of robotics and all the other peripheral related technologies with vision and sensing, that, we're entering this new age of autonomous systems and autonomy overall that I think is tremendously exciting, right? It's that type of productivity gains that historically have been allowing humanity to be able to spend time doing this, right? Like sitting here on a podcast, talk to each other, because we're not worried about, oh gosh, we have to go farm enough food so that when winter comes, we don't starve to death, because there's been such massive gains in productivity from automation in farming, right? Where simple mechanical devices are given away to GPS-guided combine harvesters. We have fewer people involved in farming in the U.S. today, yet produce dramatically more food because of automation. And I think we're going to see that in manufacturing. I think we're going to see that in other sectors as well within our lifetime. And I, for one, am tremendously excited about that.
Absolutely. Yeah, it'd be some very good stuff. So some great takeaways, guys. If you want to learn more about Ready Robotics, go ahead and go check out ready-robotics.com. ecammie, check out ecammie. Awesome event next week. If you are in the southeast part of the U.S., connect with Barbie on LinkedIn. Well, Aaron, what's Barbie's last name?
Busey.
Barbie Busey.
Busey.
Connect with her on LinkedIn. Some phenomenal stories. If you just want to see how automation and robotics is changing people's lives, fantastic story there. And then, A3 Vision Week coming up in a couple weeks. That's going to be an awesome event. And as well, make sure you're connected with Allan Gibson, Aaron Prather, and Ben Gibbs on LinkedIn. They're all leaders in their industry and passionate about manufacturing and automation, passionate about getting younger people and the workforce involved, because Aaron wants that youth around him. Sorry, 3 times in charge. 3 strikes, you're out. I consider myself up for a St. Louis Cardinals hat on top of my robot.
I'm gonna get a St. Louis jersey, a cap.
Some glitter bombs hand delivered to Jake's house that in the St. Louis colors.
Oh, geez. Well, thanks everyone for being on today. And of course, thank you to the audience on LinkedIn, on Facebook, on Ready Robotics YouTube page. We're so glad you were here. And once again, just thanks for joining us on another live Let's Talk Manufacturing event. And thank you everyone here for Allan, Aaron, and Ben for being a part of this conversation.
Absolutely.
Thanks, Jake. And thanks, guys. I really enjoyed it.
Thanks,
awesome. All right. Until the next one, guys. We'll see you later.